Welcome to C and C++ programming under EPG Pathshala. Today we will start with module 37, Managing Console I/O Operations. In the earlier modules we have written many programs where the input was needed and output was displayed. In this particular chapter we are going to see how we can format this input or output. In general there are two types of input and output in C++. One is low level input and output and second is high level input and output. In low level, it is unformatted input and output. It is just a sequence of bytes that is read or returned to the screen. Whereas in high level input and output, the formatting is done. So it is formatted input or output and the data is transferred using the blocks. It can be blocked together into a particular unit and the transfer takes place. In C++, we can format the input and output. In real life, we can relate it to a car where car has a gear, accelerator and other things which will control the speed and the direction of the car. In the same way we can control the input and output in C++. For example, if you want to display the value as 1.000 then it will be displayed as just 1 if you don't use the formatting, or if you want to display the value as 1.5000 then it will be displayed as 1.5 where zeros will be omitted. If you don't want to happen this way in our program, we can go for formatting output. The formatting in C++ will be done using the manipulators. Manipulators are nothing but the operators in C++ which will format the output data. There are different manipulators which are provided for setting the precision value, for setting the filling characters and so on. We are going to see each one of them in this particular module. This formatting input and output is done using the streams. As we have seen in earlier module, stream is nothing but a channel where the information is going to flow from source to destination. Now here we are going to see the formatting input and output where the information will not be just the bytes of characters but it will be done using the separate units. For example, if you want to read the file, it cannot be read just as a single unit. The user can decide where the file can be read as line by line or few lines at a time, or it can be printed as one block at a time. So let's start with our module. In general, each program takes some information as input and tries to produce processed information as output with the help of input process output cycle. C++ language has introduced a wide variety of features which can be used for displaying the output with the help of a wide variety of functions. C++ makes use of data manipulators directly to display the output using the output stream. Now let's see the learning objectives of this module. We are going to learn about formatted console I/O operations. We will study about managing output with manipulators. We will learn about user defined manipulators. Now let's see first the formatted console I/O operations. C++ supports a wide variety of features which can be used for designing the output. The features will consist of IOS class, functions and flags, manipulators and user defined manipulators. Now let's see IOS class, functions and flags. The IOS class consists of variety of member functions that helps to format the output in many ways. The most commonly used IOS functions that are used for formatting are the different functions and their tasks are given in the table. The first function is width, to indicate the essential field size for displaying the output value. Next is precision, to indicate the digits that are to be displayed after the decimal point of a float. Field, to denote a character that is used to fill up the unused portion of a field. Set F, to denote the format flags that can organize the form of output display. Unset F, to clear the flag that is being specified. Now let's see each function in detail. We'll start with the width function. It is mainly used to describe the width of a field that is required for the output of an atom. Because it is a member function, it is must to invoke it using an object. The width function can be able to give the field width for only one atom, that is the atom that follows instantly. The syntax is cout.width in bracket W, where W is the field width, that is number of columns. Now let's see a program to implement the usage of the width function. We'll start with a program #include IOStream using namespace std, integer main, C out the begin, the text is displayed on the screen. Now we will set the width as 25, C out dot width 25. Now we will display the number as C out, the number is 235 and the text is displayed end/n. Now this particular value 234 will be displayed where first 22 will be blank spaces and then the value will be displayed as 234. Now we will display the text as C out, the text begin greater than sign. Now we will set the width value as C out dot width 25. Now we will display the number as C out, the number 234 and the text field next. Now this particular width that we have set will be set only for this particular C out statement for 234. The next C out statement, it will not be applicable. So next statement is C out, the number 567 and then the text end/n. Now this particular 567 will be displayed as it is, the width will not be applicable to this particular statement. Now next will be C out begin, that is the text that we are going to display. Now we will set the width as 4, C out dot width 4, C out the number 234567 and the text end/n, return 0 and our program will end. Now when the above program is compiled and executed, it will produce the result as first it will display begin greater than sign, the first blank spaces and then 234 and end. Next line begin greater than sign, again some blank spaces 234, next 567 where the width will not be specified and then end. The next line begin 234567 and end. The next function is precision. It is mainly used to indicate the number of digits that are to be displayed after the decimal point while printing the numbers that are of floating point type. The default precision for floating number is 6 digits after the decimal point while printing. The precision functions tries to preserve the situation in result until it is reorganized. It is also possible to join the field specification with the precision setting. Syntax is C out dot precision in bracket D semicolon, where D is the number of digits to the right of the decimal point. Now let us see a program to implement the usage of precision function. We will start with the program hash include iostream, hash include iomanip using namespace std. Now we will start with our main function as integer main float pi is equal to 22.0 divided by 7.0 integer j, C out the text field value of pi :n. Now we will start with our for loop for j equal to 0, j less than equal to 9, j plus plus. Now we will set the width as C out dot width j plus 1, C out dot precision j and C out the value of pi and /n and our for loop will end. So inside this our width and precision will be always incremented by 1 because it is inside the for loop. Last return 0 and the main program will end. Now when the above code is compiled and executed, it will produce the result as value of pi, first line 3, next line 3.1, next 3.14, 3.143, 3.1429, 3.14286 and so on. The next function is a field function. By default, while printing the values that are having larger field width than required by the values, the ideal positions of the field are filled with the white spaces. This problem can be solved by using the fill function because it fills up the unused positions by any preferred character. The syntax is cout.fill in bracket ch, where ch represents the character which is used for filling the unused positions. Now let us see a program to implement the usage of fill function. We will start with the program hash include iostream using namespace std, integer main. Now we will have the filling character as cout.fill less than sign, cout.precision 3. We will start with our for loop for integer I is equal to 0, I less than equal to 5, I plus plus. Inside the for loop cout.width is 5, so we are setting the width to 5. Cout we are printing the value of I, cout.width 10, cout 1.0 divided by float I /n. If I is equal to 3, Cout field greater than sign, and our for loop will end. So here, as you can see, the width is specified for each and every number, and the number is displayed using the width field. Now when the I value reaches to 3, the filling character will be changed to greater than sign. So for first 3 values 1, 2, 3, the filling character is less than sign, and after 3, that is 4, 5, 6, the filling character is greater than sign. So that is what is done inside this for loop. Now outside the for loop, Cout /n, after padding is change /n, Cout dot fill $, Cout dot width 15, Cout the number 23.456789 /n and return 0. Now when the above code is compiled and executed, it will produce the result as the less than sign 1 and the value 1. So 1, 2, 3 will be printed with the filling character as less than, and then value 4, 5, 6 will be printed with the filling character as greater than sign, and then the last character is printed with the value the 23.456789 and the filling character $. Now we will see the setf function. When the width function is used, it tries to print the value with right justification by using the width that is created. But to print the text with the left justification, it is must to use the setf function. The syntax is Cout.setf in bracket argument 1 comma argument 2. Now in this syntax, the argument 1 is the value of formatting flags that are defined in iOS class. It denotes the format action that is required for both the output. Argument 2 is a bit field in constant in the iOS class, and it denotes the collection to which the formatting flag belongs. In general, there are 3 bit fields and each have the set of format flags. The flags and the bit fields that can be used for setf function are, now there are displayed in a table as the format that is required, the flag that is argument 1 and the flag that is argument 2. Left justified output will be iOS left and the flag 2 value will be iOS adjust field. Right justified output will be iOS right and iOS adjust field. Padding after sign or base will be iOS internal, iOS adjust field. Indicator, there is nothing. Scientific notation will be iOS scientific, iOS float field. Fixed point notation will be iOS fixed, iOS float field. Decimal base will be iOS : decimal, iOS base field. Octal base will be iOS oct, iOS base field. Hexadecimal base will be iOS hex and iOS base field. So formats will have 2 different argument 2 value. One is adjust field and second is float field, and the flag values will be different. Now let's see the float field bit format flag. Based on the requirement, sometimes a floating point value may have to exhibit in scientific notation or in fixed notation. So we will see these 2 formats, scientific and fixed. When the scientific is set, then the floating point values are inserted using the scientific notation. There will be only 1 digit before the decimal point followed by the particular number of precision digits. It is then followed by the uppercase letter E or a lowercase letter e depending on the situation of uppercase and the exponent value. The syntax is Cout.setf in bracket iOS : scientific, comma iOS : adjust field. The next is a fixed flag. When the flag is fixed, then the value is inserted using the decimal notation with the particular number of precision digits following the decimal point. If neither scientific nor fixed is set, then the scientific notation will be used when the exponent is less than 4 or greater than precision, or else the fixed notation is used. The syntax is Cout.setf iOS : fixed, comma iOS : adjust field. Now we will see base field format flag. The base field format flag is mainly used to show the integers in the appropriate base. At a time, one of the base field, that is decimal, octal or hexadecimal, be able to set at any time. The base field format flags manage the base in which the numbers are displayed. The default base field that will be set is decimal. The syntax is cout.setf ios : decimal, comma ios : base field. cout.setf ios : oct, comma ios : base field. Next is cout.setf ios : hex ios : base field. Now we will see the program to print a number in three different forms, that is hexadecimal, octal and decimal format using the set format field. Now we will start with our program hash include iostream using namespace std. Now we will start with our main program integer main. Now we will declare one variable as integer I is equal to 76. Now this particular number 76 we are going to display in three different formats, that is hexadecimal, octal and decimal format. So first we will change the format here as cout.setf ios : oct, comma ios : base field. Now here the format is changed to the octal. Now we will display our number in an octal format as cout octal equal to the text field, the value of the number and /n. Now we will change the format to hexadecimal as cout.setf ios : hex, comma ios : base field. Now we will print the value in the hexadecimal format as cout hex equal to is a text field and the value of the number. Now we will change the format to decimal as cout.setf ios : dec, that is decimal, comma ios : base field. Now we will display the number in the decimal format as cout, the decimal is equal to, that is a text field and the value of the number, and our program will end. Now as you can see here, we are just changing the format and the number will be displayed in three different formats, that is hexadecimal, octal and decimal. When this particular program is compiled and executed, it will produce the result as octal is equal to 114, the hexadecimal value is equal to 4c and the decimal value is equal to 76. Now let us see flags that do not have bit fields. Some of the flags does not contain any bit fields, therefore they are used with single arguments while using the setf function. In C++ language, some of the flags do not have bit fields. They are, now here the table is shown where there is a flag and the significance. The ios : show base will make use of the base indicator on output. ios : show pose, that is position, will print plus symbol before the numbers that are positive. ios : show point will display trailing decimal point and zeros. ios : uppercase make use of uppercase letters for hexadecimal output. ios keep ws miss out white spaces on input. ios : unit buff flush all streams after the insertion. ios : stdio flush the std out and std error after the inclusion or insertion. Now let us see the show base bit format flag. The show base format flag is mainly used to show the base for octal and hexadecimal numbers. Suppose if hex is set, then OX will be inserted in front of any primary insertion. The syntax is cout.setf in bracket ios : show base. Now let us see a program to show the sign of a given number using the show base flag. We will start with the program hash include iostream using namespace std integer main. We will declare the number as integer number equal to 76. We will set the flags now cout.setf in bracket ios : show base, cout.setf in bracket ios : show pose, cout the text decimal equal to and the value of a number /n, cout.setf ios : oct ios : base field, cout the text field octal equal to and the value of a number, cout.setf ios : hex ios base field, cout hexadecimal equal to is a text and the value of a number /n, cout.setf in bracket ios : decimal, that is dec ios : base field, cout the text decimal equal to value of number and /n, and our program is end. Now when the above code is compiled and executed, it will produce the result as decimal equal to plus 76, octal equal to 0114, hexadecimal equal to 0x4c and decimal equal to plus 76. Now let us see the uppercase bit format flag. The uppercase bit format flag is mainly used to show the output in uppercase. By default, the notations always appear in lowercase. The syntax is cout.setf in bracket iOS : uppercase semicolon. Now let us see a program to see the base of the hexadecimal number in uppercase using the uppercase bit format field setting. We will start with the program. Hash include iostream using namespace std, integer main. Now I will declare the number as integer number equal to 0x2abc. cout.setf iOS uppercase or iOS show base. cout decimal equal to the text field, the value of a number. cout.setf iOS oct iOS base field. cout octal equal to the text field and the value of a number. cout setf iOS hex iOS base field. cout hexadecimal equal to the text field and the value of a number. cout.setf iOS dec iOS base field. cout decimal equal to the text and the value of a number /n and the program will end. When the above code is compiled and executed, it will produce the result as decimal equal to 10940, octal equal to 025274, hexadecimal equal to 0x2abc which will be displayed in capital and decimal equal to 10940. Now next is show point bit format flag. The show point bit format flag is mainly used to display the decimal point for all floating point values. By default, the quantity of decimal position is 6. The unsetf flag is invoked to cancel the showing of all decimal values of a floating point number. The syntax is cout.setf iOS : show point. Now let us see a simple program to display the floating point value with all decimal places. We will start with the program. Hash include iostream using namespace std, integer main, float a, b, c, d. Now we are trying to give different values to these float variables. A equal to 2.34567890, b equal to 45.67, c equal to 1.23 e2, d equal to -123.5677. Now we will set the flag as cout.setf iOS : show point. cout a equal to the value of a, cout b equal to value of b, cout c equal to value of c and cout d equal to value of d, and our program will end. When the above code is compiled and executed, it will produce the result as a equal to 2.34568, b equal to 45.6700, c equal to 123.000 and d equal to -123.568. Unsetf. The unsetf function is mainly used to alter the bits to directly off. This function takes accurately one argument to turn off the bit pattern. The bitwise OR operator can be used in the argument list of the unsetf function in order to turn off more than one bit format flag of the iostream. The syntax is cout.unsetf in bracket flags to be turned off. Managing output with manipulators. The manipulators are the unique and special stream functions that can be included in the input and output statements to alter certain characteristics of the input and output. To use the manipulators, it is must to include the header file iomanip.h or iomanip in the program. The predefined manipulators and their equivalent iOS functions are shown in the following table. The manipulator is set w and their equivalent iOS function is width. Set precision, precision, set fill, fill, set iOS flags, setf, reset iOS flags, unsetf. First manipulator is basically endl. The endl stands for end of line. The endl is an output manipulator that mainly generates a carriage return or a line feed character. It is used to stop a line and flushes the buffer. There is no limit on the usage of endl. It can be used any number of times. Endl may be used several times in a C++ program. Next is set base. The set base manipulator is used to modify the base of one numeric value into another base. The commonly used base conversion in C++ language are decimal, that is a decimal base where base is equal to 10, hex, that is a hexadecimal base where base is 16, and oct, that is a octal base where base is 8. The set base manipulator is used to describe the base of a numerical value of a variable. Since the prototype of a set base manipulator is defined in iomanip.h or iomanip header file, it is must to include iomanip.h header file in the program. The hex, decimal, oct manipulators alter the base of inserted or extracted integer values. The default value of stream input and output is decimal. The syntax is set base in bracket integer base. Now we will see a program to print the base value of a number using hex, oct and decimal manipulators. We will start with our program #include iostream, #include iomanip using namespace std. Now we will start with our main function as integer main. We will declare the variable here as integer number. Now we will take a value of this number from the user. So first we will display the message as cout, enter the number. We will take a number from the user as cin number. Now we will display this number on the screen as cout, the number is the text field and the value of a number /n. Now we will display the three base values of this particular number using the cout statement as cout, the decimal base of a number is decimal DEC and the value of a number /n. Next, the hexadecimal base value of a number is HEX hex and the value of a number /n. And the last one, cout, the octal base value is OCT oct and the value of a number /n. Return 0 and our program will end. Now when the above program is compiled and executed, it will print the values as enter the number. Suppose the user has entered the number as 365, then it will print the first value as the number is 365. Then the first it will print the decimal value as the decimal base is 365. Then it will print the hexadecimal base value. The hexadecimal base value is 16D and the octal base value is 555. The next manipulator is setW. The manipulator setW stands for set width. The setW is mostly used to indicate the minimum number of characters position that a variable uses on the output field. The default field width is 0. The syntax is setW inside bracket integer w. The next manipulator is setFill. The setFill manipulator function is mainly used to denote dissimilar characters to fill the unused field width of a value. The syntax is setFill in bracket char f. Now let us see a simple program to illustrate how a character is filled in the unused field width of the value of the variable's data. Now we will start with the program #include iostream, #include iomanip, integer main. Here we will declare two variables, integer first, second. First value is 200, second is 300. Now we will use a function setFill and setW. cout setFill, the character is star. cout setW5, the value of first. setW5, the value of second. cout setW6, the value of first. setW6, the value of second, and L. Return 0 and our program will end. Now when the above code is compiled and executed, it will produce the result as star star 250 star star 350 and then star 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 250 star 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 350. For the first output, the set width was 5 and for the second output, the set width was 6. The next manipulator is a set precision. The set precision manipulator function is mainly used to manage the number of digits of a display of an output string of a floating point value. The default precision value is 6. The syntax is set precision inside bracket integer p. Now let us see a simple program to see the set precision manipulator. We will start with the program #include iostream, #include iomanip using namespace std. We will start with our main program integer main, float a, b and result. A is equal to 7, b equal to 3, result is equal to a/b. Now we will change the precision values and we will try to print the result value. So first our set precision value will be Cout set precision 1, display the value of result end L. Cout set precision 2, display the value of result end L. Cout set precision 3, display the value of result and end L. Cout set precision 4, display the value of result end L. Return 0 and our function will end. Now when the above code is compiled and executed, it will produce the result as 2, 2.3, 2.33, 2.333. The next manipulator is end-s. The end-s is a manipulator which is used to join a null terminating character /0 at the end of a string. When the end-s manipulator is invoked, it does not take any argument. This causes a null character to the output. Example, Cout in text field the slash, the text number equal to the value of a number end s, next Cout slash and end L. Here the output will be number equal to 123. The WS manipulator. The manipulator function WS stands for white space. It is mainly used to overlook the leading white space that leads to the first field. Example, char text 100, Cout enter a line of text, C in WS, C in text, Cout text is equal to the value of text. Now when the above line of code is executed, it will ask for the input as enter a line of text. Suppose we have entered hello, how are you, then it will just accept hello and it will display the value as text is hello. Next is set iOS flag. The set iOS flags manipulator function is mainly used to organize different input and output settings. The set iOS flags manipulator execute the same functionality as the setf function. The flags represented by the set bits in f are set. The syntax is set iOS flags in bracket long h. Reset iOS flags manipulator. The reset iOS flags manipulator performs the same function as that of reset f function. The flags represented by the set bits in f are reset. The syntax is reset iOS flags in bracket long f. Now let's see a program to demonstrate the use of built-in manipulators. We'll start with the program hash include iostream, hash include iomanip using namespace std. Now we are going to make use of different manipulators in this particular program. We'll start with the main function integer main, double working hours is equal to 50.0, double pay rate is equal to 15.00, double gross income equal to 0.0, Cout fixed show point, Cout set precision 2, gross income is equal to working hours into pay rate, Cout gross income set W 6 and the value of gross income end L, Cout the text working hours set W 6, the value of working hours end L, Cout the text pay rate set W 6, the value of pay rate and end L, return 0 and our program will end. Now when the above code is compiled and executed, it will produce the result as gross income is equal to 750.00, working hours 50.00, pay rate 15.00. User defined manipulators. In C++ language, it is not possible to use predefined manipulators to format the output, but it is also possible to create a user defined manipulators according to the user's choice. The syntax is ostream ampersand manipulators in bracket ostream ampersand output, and the code will follow, which will be the set of statements, return output and the function will end. For example, ostream ampersand currency in bracket ostream ampersand ostr, Cout fixed set precision 2, Cout rupees, return ostr and our function will end. So here we had created our user defined manipulator currency as rupees. Now let's summarize our module. The width function is used to give the field width for the atom. The precision function is mainly used to indicate the number of digits that are to be displayed after the decimal point. The fill function fill up the unused positions by the preferred character. To print the text with a left justification, it is must to use the setf. The base field format flags manage the base in which the numbers are displayed. The show base format flag is mainly used to show the base for octal and hexadecimal numbers. The show point bit format flag is mainly used to display the decimal point for all floating point values. The unsetF function is used to alter the bits to directly off. The endl is an output manipulator that mainly generates a carriage return or a line filled character. The set base manipulator is used to modify the base of one numeric value into another base. The set w is mostly used to indicate the minimum number of character positions that a variable uses on the output field. The set field manipulator function is mainly used to denote a dissimilar character to fill the unused field width of the value. The set precision manipulator function is used to manage the number of digits of display of an output stream of a floating point value. The endes is a manipulator which is used to join a null terminating character /0 at the end of the string. The ws manipulator is used to overlook the leading white space that leads the first field. The set ios flags manipulator function is mainly used to organize different input and output settings. In C++ language, it is not only possible to use predefined manipulators to format the output, but it is also possible to create manipulators according to the user's choice.